So we are now going to investigate the last type of chemical reaction for this chapter. That chemical reaction subtype is oxidation reduction or redox reactions. Redox reactions are all about the loss or gain of electrons. And I say or, but in a redox reaction, the loss and gain of electrons always happen within that same reaction. They always go together, kind of like peanut butter and jelly or Tom and Jerry. But different species in a redox reaction either gain or lose electrons. The species that loses electrons in a reaction is oxidized. Conversely, the species that gains electrons is reduced. So those are the definitions of oxidation and reduction. When you combine them together in a chemical reaction, you get a redox reaction. And just like with the conservation of mass, matter can't be created or destroyed. If something loses electrons, then something else in that reaction must gain electrons. So that's why one cannot occur without the other. So you need to remember the definitions of oxidation and reduction. One way that I like to remember those definitions is this little mnemonic, Leo goes Gur. At least that's the way that I was taught when I was in school years and years ago. Leo goes Gur. And Leo goes Gur because if you lose electrons, you are oxidized. And if you gain electrons, you are reduced. So that's one mnemonic that you can use to remember those terms, oxidation and reduction. Another one that I've also heard folks use, particularly some instructors at Rose, uses this mnemonic oil rig, which I guess is appropriate for being in Oklahoma, an oil state. The mnemonic oil rig stands for oxidation is loss of electrons, and reduction is gain of electrons. So whatever floats your boat, whatever helps you to remember those two terms and the definitions. So knowing those definitions and knowing something about the charge of a species, it'll be easy to determine if something is oxidized or something is reduced in a redox reaction. So looking at this example down here, we can clearly see that the zinc solid in this reaction, as a reactant, as a product, it now has a +2 charge. And if a species doesn't have a charge written next to it, it is a charge of a big fat 0, big fat goose egg. So from zinc to go from a 0 charge to something that is more positive, a +2, the only way that can happen while it's still being zinc, while it's still not changing the numbers of protons, the only way for that to happen is for zinc to lose 2 electrons. And so since zinc has lost 2 electrons and oxidation is lost, we say zinc in this reaction is oxidized. And copper started as a +2 charge as a reactant and became a big fat 0 charge as a product. So those 2 electrons that were lost by zinc when it was oxidized, those 2 electrons were gained by copper. So we would say that copper in this redox reaction was reduced. So you should be able to determine if something is being oxidized or reduced using these two definitions of oxidation and reduction. As we go on in subsequent videos, you'll see that many redox reactions can also be classified as either combination, decomposition, or single displacement reactions. The way that this reaction is written, it's not that apparent. We're going to see some other examples where you can further classify certain redox reactions as one of these 3 categories. But for right now, you should know the definitions of oxidation and reduction, and be able to identify what is being oxidized and what is being reduced based upon those definitions. You should also be able to say something about the reducing agent or the oxidizing agent for a redox reaction. And I remember as a student, I always got a little bit confused with this because you would think, oh, the reducing agent, that's the thing that's reduced, right? No. The reducing agent in a reaction is that species that is oxidized. What that means is that if it's a reducing agent, that means that species is reducing something else and becoming oxidized in the process. Similarly, oxidizing agents are the ones that are reduced. They are oxidizing something else and in the process are being reduced. So the species that is reduced is the oxidizing agent. So in this example that was from the previous slide, we said zinc, because it's lost 2 electrons, it is oxidized, and copper, since it gained 2 electrons, is reduced. But if I was to ask you what is the oxidizing agent, the oxidizing agent is the species that is reduced or gains electrons. So what is that oxidizing agent in this reaction? That oxidizing agent is what's reduced, which is the copper. Similarly, the reducing agent is what is oxidized. And what was oxidized in this reaction? The zinc. So the zinc is the reducing agent. So you should know those terms, reducing agent and oxidizing agent, and be able to determine those in a redox reaction. So in subsequent video, so this is the end of this video. In subsequent videos, we're going to talk about how to use those terms, reduction, oxidation, reducing agent, and oxidizing agent, how we can use those along with rules on oxidation numbers to determine species in a redox reaction.